Thank you very much for joining us today. Welcome to the webinar. We are delighted to have the opportunity to share the information about the Geotube shoreline systems with so many of our industry colleagues. Thank you very much for your time. It is most appreciated, and your interest in joining us. My name is Kevin Bossy. I'm the CEO of Bishop Water Technologies. We are an Ontario-based company that specializes in low-energy, easy-to-use solutions for solids management and nutrient removal. Among the key technologies in our solutions portfolio are the TenCate Geotube Geotextile containers. Bishop Water has been using geotubes for more than a decade to collect, dewater, and consolidate slurry materials such as wastewater sludge, storm pond sediment, and contaminated sediment. We've also had the opportunities to apply them to more challenging waste materials that come from industrial processes, such as mining and food processing. What's interesting, though, is that the geotubes were originally developed not for sludge dewatering, but for shoreline stabilization and protection. Today, we'll talk more about the heritage and the development of more advanced geotube systems that can help us mitigate some of the shoreline issues we're facing in Ontario and across Canada. I'd like to introduce my co-presenter, Mark Raincourt, who will take us through the next part of this presentation.
All right, thank you, Kevin. Yes, so my name is Mark Raincourt, a process specialist with Bishop Water Technologies. My role is to focus primarily on understanding the process challenges our clients face, and then developing and applying economically and environmentally beneficial solutions. So as Kevin mentioned, we have over a decade of experience with Geotube technology, and we'd like to direct that application experience to something innovative for Ontario. And that's what we're here to talk about today, which is to present TenCate Geotube systems as a durable, resilient solution for shoreline protection. Okay, let's just do a quick overview of today's agenda. So we're going to cover several topics over the next 45 minutes or so. We'll start off by reviewing some of the shoreline erosion issues that Canada is facing and some of the conventional approaches that have been used up to now to deal with them. From there, we'll discuss how Geotube can be a viable alternative and discuss the various types of Geotube systems that we can provide and the many ways they can be implemented for shoreline applications. So yes, Geotube is made of synthetic fabrics, and we are often asked about the durability of these materials compared to, say, harder shoreline systems like rock and steel. So we'll talk about the ways these materials and systems are tested to validate their strength and performance. Then we'll present some interesting case studies to illustrate what we've been talking about throughout the webinar, and finally end the session with your questions. So before we begin, I just want to mention a few housekeeping items. First, we'll be recording the webinar, so we ask that everyone please keep their microphones on mute. If you'd like to ask questions, please use the chat function. You can access this by clicking on the chat icon in the top right corner of your screen and simply type your question in the dialog box, which you'll see near the bottom. For those that have joined by phone, you're welcome to email your questions directly to my email. That's mark@bishopwater.ca, Mark with a C. We won't address questions as they come in, but rather we'll answer them at the end of the webinar just to keep us on schedule. So if there happen to be more questions than we can answer during the session, we'll address them by email and send those responses out to everyone registered. We'll also follow up with an email that has a link to the recorded webinar and some additional information about Geotube shoreline systems. All right, so to kick us off, let's briefly review the shoreline challenges that residents along many Canadian waterways, such as the Great Lakes, are facing. Unfortunately, for the past few springs, we've certainly seen more and more of these types of images where high water, waves, and storms are causing severe damage to public and private property, as well as buildings and infrastructure. So we know the property owners are worried not only about loss of land, but also the potential loss of their homes. We've been contacted by several landowners that are on the shorelines of Lake Erie and Lake Ontario who have either lost previously installed shoreline protection systems to water and ice damage, or they need a new one installed for the first time. So in conversations we've had with the landowners, they tell us they're looking for a reliable and affordable way to stabilize and protect the shoreline, and sometimes they need a solution installed very quickly. So we've also learned that the shoreline management plans that are being developed in Ontario are looking for ways to balance environmental concerns, economic concerns, as well as the needs and concerns of the surrounding community. So that largely means protecting property from erosion and flooding with solutions that increase shoreline resilience. So this photo shows an example of some very serious erosion occurring along Lake Erie. So this erosion has occurred over the last 40 years. You'll see in the picture there, the yellow line down below is from 1978, and the red line is from 2010. So about 40 years, and it's bringing the top of the bank very close to a developed property, and eventually a roadway as well. So in just one region of Elgin County, shoreline erosion is estimated to be threatening about $34 million of development. So if we expand that to include the north shores of Lake Erie and Lake Ontario, I'm sure we would easily find hundreds of millions of dollars of property at risk. So are conventional methods working? Well, many shoreline properties already have some type of shoreline protection system, whether it be armor stones, sheet pilings, gabion baskets, etc. Unfortunately, in many cases, these systems are only protecting one property and often fail after a period of time. So on this slide, we reference information from the Elgin Shoreline Management Plan regarding why these systems for individual lots often fail. So erosion, engineering issues, lake bed downcutting, and inadequate size of the protection system are among some of these reasons. So as the photo illustrates, these conventional approaches can often be destroyed once a section of it is undermined by erosion. So next I'll talk about geotube systems, and I'll explain why these types of failures are very unlikely for a properly engineered geotube system. So a proven alternative. First, let me say that TenCate Geotube Geosynthetic Systems are not new technology. They have been used worldwide for many years, including here in Canada, for a wide range of coastal and inland waterway applications, such as revetments, sand dune cores, breakwaters, and land reclamation, to name a few. So the photos on the right are a few impressive examples of how durable and reliable these systems are. The top photo you see there shows several very large geotubes stacked on top of each other to stabilize and protect a massive vulnerable bluff, as well as the development that's very close to the edge. The bottom left shows the coastline of Atlantic City, New Jersey, where geotubes are protecting the beach, as well as hundreds of millions of dollars in real estate behind them. These were initially installed about 25 years ago and continue to provide reliable protection today. And finally, in the bottom right, that's Amwaj Island. That's an engineered island in Bahrain in the Middle East. This installation used a double layer of sand-filled geotube containers that run along the entire perimeter of the island, providing a strong, stable core, which is covered by stone. One other thing I should mention is that geotube is often used as a generic name for geotextile bags. It's not actually the case. Geotube is a registered TenCate brand of highly engineered products made from high-tech fabrics. So there have been several iterations of geotube fabrics over the years, and these have been incorporated into very innovative and advanced products. All right, as Kevin said at the beginning of the webinar, geotube systems were originally developed for shoreline protection. The first one was installed almost 60 years ago, and since then geotube systems have been installed in more than 50 countries to address various environmental and economic challenges. So these installations have helped avert millions of dollars in property damage and also played a key role in reclaiming land and reestablishing sensitive and important wetlands, which we'll talk about later on in the case studies. So I'd like to talk about how geotubes can provide both environmental and economic benefits over some of the other options. So first, the sheer size of a geotube. Once it's full, it becomes a monolithic structure that weighs literally hundreds of tons. And because of that and the way it's installed, it's very unlikely for a geotube to be compromised. So in short, it's a protection system that's going to last for a very long time, unlike something like the stone wall we saw just a couple of slides back. As we all know, the cost of install is always factored into the decision-making process, and geotube systems can often be installed at a lower cost and more quickly than other projects involving stone or other heavy materials. And one of the primary reasons for that is because sand and sediment is available almost everywhere, and sometimes the material can be dredged right from the water body itself to fill the geotubes. But even if it can't, there's usually a source pretty close by. Rock, on the other hand, especially large rocks that would be used for a shoreline system, are less abundant, sometimes need to be transported a long way and at significant cost to reach the installation site. So these issues relating to availability of materials and transportation also actually contribute to a lower overall carbon footprint for installing a geotube shoreline system. And TenCate has actually designed a carbon calculator that can compare a geotube shoreline system to one that is made from arbor stone, for example. And in the majority of cases, geotube systems will offer a significantly lower carbon footprint. So once installed, a geotube can be covered with rocks, sand, plants, or whatever helps it blend in with the surrounding environment. However, if they are to remain exposed, geotubes are available in green or tan colors to help them blend in. So most geotube projects are permanently installed, but there are instances where they are temporary. And in these situations, geotubes also have the advantage of being removed more easily and for lower cost than other structures. So, typically the containers are simply cut open and the sand can be either removed for distribution locally or transported off-site. All right, so a softer approach to shoreline protection. Geotubes are also recommended for use in hybrid engineering approaches that integrate soft, green, or natural-based methods in combination with structural solutions to create a stable, living shoreline. So one organization, SAGE, which stands for Systems Approach for Geomorphic Engineering, and it includes members from the U.S. Army Corps of Engineers and the National Oceanic and Atmospheric Association. They recommend geotextile containers as a viable solution for strengthening sand dunes. And according to SAGE, the geotextile tubes help anchor sand and buffer inland areas from waves, flooding, and erosion. So our discussion so far has been about geotube containers in general. I'd like to get into a little more detail now and look at the different types of TenCate geotube systems. The solutions we'll be discussing in addition to geotube containers are sand-filled mattresses and the lake embankment systems. So many of you will already be familiar with geotubes and know about the work Bishop Water has done for dewatering and solids management. So these are large tubular containers made from durable engineered fabrics, and as you've already seen, these are used for erosion control and flood protection. And they can be really big. They're often manufactured to standard sizes, but we can also order custom sizes from TenCate. Some of the largest geotubes we know of that are in shoreline systems have been up to 200 feet long, 55 feet in circumference, and filled to heights of about 8 feet. For long expanses of shoreline, geotube containers can be arranged end to end, and they can also be stacked in multiple layers to protect more elevated areas. You can see in the before and after photos to the right, this installation has helped rebuild the shoreline and protect it from further erosion. So the way a geotube system works is pretty simple. Often there's some site preparation required, which may need some excavation or leveling. Then a scour apron with an attached anchor tube is placed down to provide a stable surface for the geotube to rest on. And I'll talk a little more detail about the scour apron and anchor tube in the next slide. But we pump the material, which is diluted into a slurry, into the geotube through a filling port on top. The larger geotubes might have several filling ports, and material can be trucked in and diluted to make a slurry, or as mentioned, dredged directly from the local water body. In some cases, contaminated sediments have actually been dredged and pumped into geotubes, which then contain the material on site as part of a land or shoreline structure. As the geotube's filling, the porous woven fabric allows the water to escape while retaining the solids and consolidating them over time. So once it's full and the water's drained out, the material inside does become quite dense, which helps the geotube behave as a massive, virtually immovable structure. So here's a bit more about how the scour apron and anchor tube work. You can see in the diagram on top, the anchor tube is basically a small, much smaller version of the geotube. It's also filled with sand or sediment, and its purpose is to hold the scour apron in place. And ironically, the way it works is that it actually falls victim to wave action. So once that anchor tube is filled and set in place, the wave action will form basically a trough that the small tube will eventually sink into. And wave action will then cover it in sand. And in this way, the anchor tube helps hold the scour apron in place and prevents the same action from destabilizing the main geotube. So the photo on the bottom, it shows, you can see the tan-colored geotube that was uncovered after a major storm event. You can see the surface of the black scour apron in the middle, and just to the left, the anchor tube, which you cannot see, is buried, doing its job of holding the scour apron in place. So one of the most common applications for geotubes is to be used as a sand core that is incorporated into sand dunes or other shoreline structures. Of course, a geotube that's forming part of a sand dune would be covered with sand, but they can also be covered with any other type of material, such as soil, rock, or even plants. And many geotubes are left uncovered. However, since the fabrics are designed to withstand pretty much anything that nature can throw at them. And we'll talk more about the durability a little later on in the presentation. So cliff and bluff protection. Here's another diagram that shows how a combination of larger and smaller geotube containers can be stacked to protect a very high vulnerable bluff, similar to the photo that we showed earlier. So in this example, the slope might be about 30 feet high. And if we assume that this bluff is also affected by wave action, then there would be a scour apron and anchor tube also installed at the base of the stack. So up to this point, we've looked exclusively at geotube containers along the shoreline, but there are plenty of applications where they are used offshore, either to reduce wave energy or to restore beaches, or both. These photos show a pretty dramatic transformation to a beach in Mexico that was damaged by a hurricane. And in this case, geotubes were installed to protect the shoreline by dissipating wave energy and also helping sand accumulate on the lee side of the breakwater to re-nourish the beach. So here's a diagram just to explain how this breakwater process works. The brown dotted line that runs under the geotube shows the sand profile before beach restoration begins, similar to the hurricane damaged beach from the previous slide. And once geotubes are installed, they will reduce wave energy, but still allow water to flow over and bring sand onto the beach. And any sand that's deposited is then held in place by the geotube. This all occurs naturally, and sand will continue to accumulate over time. And eventually the dotted red line that you see would represent the new profile with significant sand accumulation. And the geotube would be virtually covered with sand. So waterfront and wetland projects. In addition to beaches, geotubes have also been used to restore wetlands and have become important foundational structures for many urban waterfront projects. Some innovative approaches have combined dredging activities with geotube installation. In these situations, accumulated sediment is removed from the waterfront areas and then pumped into geotubes that will remain on site. As we mentioned, the geotubes could remain exposed or be covered with material to achieve the desired aesthetic. So I'm not sure if anyone could spot the geotubes in the top photo, but they're actually under the green strip of land along the left side of the photo. Kevin will tell you more about that project, which is in the UK when we get into the case studies. And the lower photo just shows a damaged beach barrier on Lake Erie. There's no geotubes here, but it's just one example of a site where geotubes could be used to restore a beach area. All right, sand-filled mattresses. I don't know if a sand-filled mattress would be too comfortable to sleep on. However, they are used very successfully to stabilize slopes and prevent erosion. So as you can see, the mats are composed of a series of tubular sections that's laid parallel to the slope. And similar to the geotubes, the sand slurry is pumped in from the top, water drains out, and the sand remains. So the top photo shows an example of how a large geotube container can sometimes be combined with the sandfill mattresses to provide extra shoreline protection along with slope stabilization. So the mattresses are designed to remain exposed. Because of that, they are engineered to be highly resistant to both abrasion and UV light. The fabric is also unique in that it's designed to trap and hold soil on the surface of the mattress. This material will also trap seeds and enables the mattresses to quickly establish a covering layer of vegetation. So the photos on the right show sand-filled mattresses and what appears to be a creek or drainage canal, and you can see the dramatic transformation from the top photo as vegetation begins to become established, and then the bottom photo where the mattress becomes virtually invisible, fitting in seamlessly with the natural environment. All right, so another innovative solution in the TenCate lineup is the lake embankment system. It's very similar to the other geotubes we've seen, but these containers are typically smaller in circumference and fill height and generally applied to inland water bodies. These photos show a single layer embankment system being installed in an urban water body, but there are cases where multiple layers could be used to create a taller structure if needed. So again, they can be filled with dredge materials from the water body if possible. So for example, if this lake was suffering from an accumulation of sediment, that material could easily be removed to fill the tubes. And once the installation is finished, any type of aesthetically suitable material can be used to cover the geotubes. So here they've covered with soil and grass in order to make them completely invisible. And it's a great example of how the natural landscape was able to be maintained as opposed to, say, a rock structure or gabion basket, etc. All right, so hopefully by this point in the webinar, we've shown you that geotubes provide a great deal of flexibility for shoreline solutions. And the embankment system literally is a flexible system. You can see in these photos that the geotube is quite capable of following the rounded contours of the water feature, even where there is considerable curvature of the landscape. So a crew can quickly install it by pegging the geotube into place using wooden stakes or piles, as shown in the diagram there, then filling the container to the desired height. And some backfill might be required to level it, and then any top covering can be applied. All right, so I'll turn the presentation over to Kevin, who will go into more detail about the durability of the various geotextile materials from TenCate, and then review a few case studies for you.
Thank you, Mark. Really appreciate it. That wraps up the types of geotube applications. I'd like to start by giving you a closer look at the materials that the geotubes are made of. First, we're going to look at the GT1000. This is probably the most commonly used material for geotube shoreline systems. The GT1000 fabric is woven from polypropylene multi-filament yarns The material is quite thick, extremely durable, and inert to biological degradation. TenCate has also developed an industry-leading method to create the seams of the containers that maximizes the integrity during filling and operational life. The seaming process is so effective that the seam strength is upward of 80% of the ultimate fabric strength. This is dramatically better than the industry standard, which yields 50% of the ultimate fabric strength. Most importantly, you can get GT1000 in any color as long as it's black or tan. More recently, TenCate introduced a new fabric called TC1200. This is a composite material that incorporates 3 different woven and non-woven materials to create a very durable shoreline system. The top layer is made of a dense crimpled fiber that not only adds impact and abrasion resistance, but also traps soil in the fibers. We saw this material when we looked at the sand-filled mattresses, but is also used for the larger Geotube containers. The lower photo shows an application where several Geotube containers made from TC1200 material have been used to stabilize a riverbank that was experiencing severe erosion and still continues to be used as a place to dock boats. It's important to note that TenCate dedicates a great deal of time and resources in the continuous improvement and performance testing of the Geotube technology. Each product undergoes significant testing before any performance claims are made, and it is available for sale. These next slides will show you the types of tests that were applied to the latest Geotube fabric, TC1200. We often have questions about the durability of Geotube fabrics, and these tests, combined with the application experience, provide the proof that the products can deliver what they promise. Let's look at the abrasion testing. The TC1200 was exposed to an industry standard abrasion test. A rotating drum tester filled with basalt gravel slurry completed 80,000 cycles. After analyzing the sample, the results showed that the TC1200 retained over 90% of its strength. Next is UV degradation testing. We're often asked about this, especially in situations where the Geotube container will not be covered or can potentially become exposed as a result of wave or weather activity. Once again, TC1200 underwent a standard industry test for UV exposure. This is an accelerated testing process that simulates long-term exposure to damaging UV light. The results show that the TC1200 material retains 96% of its original strength after 4.35 years of exposure to UV light, consistent to what would be experienced in Southern Ontario. This means it would take 54 years for an exposed Geotube container to reach 50% of its ultimate strength. One of the concerns is impact testing. Impact resistance is one of the most commonly asked questions about Geotube containers. Debris, ice, even watercraft could all come in contact with an exposed Geotube container and potentially cause damage. So, and again, there is an industry standard test to evaluate the ability of a fabric to withstand the impact. And the folks at TenCate, and I'm sure there's multiple volunteers for this, take a 2x4 building lumber and fire it at 100 kilometers per hour at samples of the TC1200 fabric. They do it 3 times for each sample and then take a look to see what happened. The results show that the fabric experiences no ruptures and shows only minor damage, proving that the TC1200 can survive multiple impacts in the same location from objects traveling at exceedingly high speeds. Developing engineered shoreline systems. Now that we know about the types of Geotube systems, the materials that are made of, and the ways that they can be applied, we can talk a bit about the first steps in any project delivery. Whether the shoreline system is for an individual property, a group of properties, or a municipal waterfront development, there are multiple groups that can become involved to assess the site, design a solution, review the solution and provide permits, supply the materials, and perform the installation. Bishop Water has been doing business in Ontario and throughout Canada for more than 20 years and has developed strong relationships with many of these organizations. We are in an ideal position to assist in several of the project delivery steps and bring in the appropriate project partners to handle others. TenCate brings decades of global experience and success. One of the reasons why we are so confident in our abilities to deliver a comprehensive, well-designed shoreline system is because of our strong relationship with the Geotube manufacturer, TenCate. Through TenCate, we have access to their team of highly experienced experts that can provide us with assistance in the design and installation of Geotube systems. This team leverages the knowledge and experience that TenCate has accumulated by delivering shoreline projects around the world for more than 50 years. As you've learned through this webinar, there is a broad range of standard and customizable products that can be applied to shoreline projects, and TenCate provides powerful tools to collect the information and specify project parameters. So this brings us to the end of the product information section. Now I'd like to run through a couple of case studies, examples, and then we'll be happy to answer some of these questions. First is the Atlantic City, New Jersey, which we had right at the beginning, a photograph of. It's very well known for its beaches and boardwalk, but over a 12-month period starting in January of 1993, the area lost more than 100 feet of beach in some areas. To protect the homes and businesses and hotels, the city decided to try installing 6,000 linear feet of geotube to form a very strong sand dune core. These were then covered with sand and dune grass. Shortly after the work was completed, Hurricane Lewis brought massive waves that eroded the beach in front of the geotubes, but not behind. The geotubes continued to be working. Years later, in 2012, another major storm caused damage to an unprotected section of the beach, but the areas protected by geotube were relatively unaffected. The original geotubes installed over 25 years this month are still providing shoreline protection for this recreational destination. Round Lake, Ontario. Next is a more local example. This is an installation for an individual property on Round Lake, Ontario, about an hour north of Ottawa. A homeowner had experienced severe ice damage over several winters to a retaining wall, as you can see in the picture at the top. As the damage worsened, the shoreline became more and more vulnerable to erosion. The problem was also compounded by high water in the lake, which also serves as a reservoir to power a hydroelectric dam at the outflow. Rather than rebuild the retaining wall in the same manner as before, the homeowner decided to try installing a 100-foot geotube to provide a stable core for a new stone structure. So in the summer of 2013, a geotube, scour apron, and anchor tube were installed, then covered with sand and a single layer of armor stone to conform with the site aesthetics. The solution ended up costing a lot less than a wall made entirely of armor stone, since a lot less rock had to be transported to the site. After several winters, the shoreline system is undamaged and is not shifted from wave or ice action. So this is a NASA Wallops Flight Center in Virginia in the United States. This is a great example of how an emergency geotube system became a permanent installation. It started in 2006 when a storm caused serious erosion to the beach on Wallops Island, Virginia, where a NASA Flight Center is located. The erosion threatened a launch pad on the island and required immediate attention to ensure planned rocket flights could go ahead in the following year. Nearly a mile of geotube were installed to stabilize the shore and restore the beach. In April of 2007, the geotubes were hit with their first major storm, but they did their job, while also helping to retain significant sand on the beach. This can be seen in the photos which show the geotube at the time of installation in the top photo, and covered in sand after the storm in the lower photo. Our final case study is a very innovative project in the UK to restore a reed bed and strengthen a spit that separates a river from a shallow engineered lake, called the Salhouse Broad. The Norfolk Broads are in Norfolk and Suffolk, and they're a significant area for tourism and recreational activities. Erosion over the past few decades had narrowed the spit to just 2 meters in place. The Broad Authority decided to use geotube containers to create a barrier for the reed bed. The top photo shows the placement of the geotubes. The area inside the barrier would then be filled with sediment dredged from the river. Vegetation would be brought in from a neighboring site and planted in the sediment and on to the geotube containers. The lower photo shows the re-established reed bed and the much wider spit. The geotubes were completely covered in vegetation and invisible along the right side of the spit. We have a brief video to show about this project that we think provides a very good overview of the geotube installation.
In recent years, the European-funded PRISMA has focused on the improvement of dredging techniques and the potential uses of sediment. One such project was at Salhouse Broad, reusing 12,000 cubic metres of sediment to recreate a reed bed as it was in 1946. At the same time, creating a biodiversity action plan habitat.
The project here at Salhouse Broad consists out of several stages. The first stage is the elder pole piling and place them on the waterline as it was in 1946. The second stage is to place the TenCate Geotube units, fill the dredge sediment from the river, and once they're filled, backfill the area with more dredge sediment. The next phase is to transplant vegetation and place it onto the Geotube units. This will be held in place by the TenCate Geogrid.
As conventional piling constructions would not be feasible and Alder is local to the Broads, it was the sustainable choice for piling and anchoring points for the geotubes that hold the reclaimed dredgings. The geotubes are an essential aspect of the project. As the Broad is filled with soft sediment to a depth of around 6 metres, the geotubes rely on mass and gravity to stay in place. Once filled, the geotubes would act as underwater retaining structures for the main body of the backfill. First, the dredge sediment was transported to the site by barge, then transferred to a pre-processing unit before being pumped into the geotubes. The filling of a geotube by concrete pump underwater is hugely innovative and was the most challenging aspect of the project, as the fill level of the geotubes directly influences the potential vegetation types. Once the tubes were filled to the correct level, a layer of TenCate geofelt was placed on top to help protect the tubes prior to backfilling and planting. Then it was time for more dredgings to be pumped to provide the backfill as a base for the new reed bed. Once the backfill was completed, it was covered with vegetation scraped from a nature reserve nearby. The project at Salhouse Broad has received international attention, a certificate of recognition from the Working with Nature initiative, and a recommendation from the Waterways Renaissance Award of the Canals and Rivers Trust for Innovation.
It's now October 2013 and you can see the spit here just behind me. Quite a lot of vegetation has established. We have over about 30 species of different vegetation, with the common species like common reed mace and common reed, but also the more rare species like marsh fern, milk parsley, marsh thistles and marsh nettles as well. Quite a diverse selection. I think over more than 30 species has been recorded last September.
I think looking at that video, it's a pretty remarkable transformation that really shows the advantages of the Geotube technology for this type of restoration effort. Certainly wouldn't be many other options to increase that spit in such a way that would restore it to how it was. To wrap up, I'll briefly just like to mention some of the other ways that Bishop Water has applied Geotube technology. These applications have, of course, greatly contributed to our depth of knowledge and confidence in the technology. As I mentioned, we've been in business for over 20 years, and Geotube has been one of our core offerings over that period of time. We've installed Geotube systems right across Canada, primarily for use by municipal wastewater systems to collect and dewater sludge. These systems provide significant cost savings over long-standing conventional ways to handle sludge, and also provide stabilized solids that can be applied to land as soil amendments. Municipalities also often use Geotube containers to remove accumulated sediment from stormwater ponds. Dewatering on site is a great advantage since it reduces the amount of trucks traveling through the community and the associated transportation costs. In some cases, the sediment is reused on site or a nearby location for landscaping. We've used geotubes to help mining companies and other heavy industries remove contaminated sediments from decommissioned sites. Construction companies have used them as part of an excavation activities and have even used the full containers to form the bases of new buildings. Food processors are increasingly using Geotube containers to collect solids from watchwater and process waste such as peels and spuds. We're developing new systems to help them reuse the water that is then released from the geotubes to reduce sewer loading and freshwater demand. We also see tremendous opportunities for this technology to reduce the amount of nutrients that are released to our waterways from activities on animal and produce farms. Who we are. And finally, our standard sign-off page. I think we've covered most of this through the presentation, but what I'd like to highlight is our technology focus as a company. We've grown over the past 20 years. We've dedicated a great deal of effort to developing technologies and systems that provide economic and environmental benefits to our clients and their communities. We do this by designing systems that are reliable, easy to operate and maintain, have low energy requirements, and require little infrastructure around them. Of course, we couldn't do this without a great team, and we're very proud of the dedication that our team shows in working collaboratively with each other and our partners to continually improve the solutions we offer. Thank you very much for the attention during the presentation, and we'd be very happy to answer some of your questions.
All right, so yeah, we did have a few questions come in, so feel free to anybody who wants to stick around or type in a question. We'll stay on for the next little while to answer any of those. So there are a couple here. So the first question that came in was regarding beaches. So I think that was Corey who asked the question: is there a use for the product for a beach that combats erosion while still allowing recreational use of the beach for citizens? The answer is definitely yes. In fact, if anybody's been down to Mexico for a little winter vacation, you might often see the geotubes far offshore that are acting as water breaks, similar to those examples we showed early in the webinar, where it's reducing the wave energy, and that the flow of the wave is still coming across the geotube and basically entrapping the sand. So it can be set up in a way that's unobtrusive, to the people still enjoying the beach, right? It's set off far enough offshore, and the geotubes don't necessarily have to be arranged end to end, right? There can be separation between them, but overall you get an effect of that erosion protection and re-nourishing of the beach. So definitely, yeah, it's been used quite a bit for that.
And also, Mark, in Cancun, for example, if you're ever laying on the beach, a few centimeters below you, you're actually laying on top of a series of geotubes as well. So they can actually be installed into the core of the beach. So definitely compared to, say, the putting of armor stone or rock, there is still significant public access with the use of a soft structure such as a geotube.
Okay, we have another question. Gord typed a question: is there an application that provides extended flooding protection, so used as a berm? So we didn't have anything in this webinar, obviously, but as you saw, the geotubes can be used as part of a stable berm or sand dune. We'll have to check, Gord, see if we can send something in the follow-up information regarding that, something specifically for flood protection. Kevin, I'm not sure if something comes to mind, or if
certainly not here for flood protection. I can't think of a application, but we can get hold of something that we can provide to you, Gord, on that regards.
Okay. All right, so another question: when the slurry is pumped in, does dirty water seep out? Well, I mean, it depends on the material, I would say. I mean, when we use geotubes for dewatering, we're often using a polymer, right, that will capture more solids, but a lot of these shoreline systems, polymer's not used. So, really it wouldn't be concerned, right, if you're dredging material that's in the water body, right? If some of those solids come out, which they will, I mean, you're not going to capture 100% of the solids that you're pumping into the geotube, but the vast majority of solids are retained in the tube.
Yeah, at Round Lake, our permit, we had to be consistently below 25 milligrams per liter of TSS coming off the geotube, and we never exceeded that throughout the testing. There was typical sediment collection was done at the water's edge with erosion, sediment fencing, etc., to ensure that there was no sediment going back into the water body. But as Mark said, typically you will see very low, because we're generally using sand, it will fall out of suspension quickly, and you'll see very low. It won't be dirty water. It will be very low solid water. And as I say, typically below 25 milligrams per liter of TSS.
Yeah, and typically the material that's selected to be used in a shoreline application is something that's going to be suitable to use, in that water body, right? I mean, we did mention at times, contaminated material was used, but you would never bring in contaminated material from say, another site to use in a water body, right? If there was contaminated material in that water body itself, well, then it might make sense to contain it locally. So I hope that answers your question. Let's see. So question about cost. When you say this costs less than armor wall or armor stone, what percentage cost? I guess. Well, as you can see from the presentation, there's various methods of creating a shoreline protection system. So to give you an absolute cost, it's never easy without reviewing the actual project. Availability of materials, how much water work is needed, what pumping equipment is needed. Obviously, all factors that'll come into play. But I guess as a rule of thumb, what we could say is about $400 to $600 per lineal foot installed price would be a good budgetary number. So to give you a percentage, it's going to vary so much from project to project. But certainly, if there was something specific you had in mind, you're looking for some budgetary numbers on, we could certainly help provide that for you. So a question from Jane: what are the known chemicals in lesser compatibilities, pH range, hydrocarbons, etc.? Kevin, I know you're probably more versed to answer that question than myself, just regarding resistance of the Geotube material, or if somebody, I don't have it in front of me, but they are highly resistant to basically, inert to most harsh chemicals.
Yeah, we've done environments where we've been doing pHs of 11, 12, and acidic environments as well, and we've never seen any degradation in the Geotube. And we certainly got all of that range. In fact, one of the pictures that we showed in there was in regards to hydrocarbons. We do work extensively at oil and gas refineries, cleaning up their dirty storm ponds, which are highly have a significant portion of hydrocarbons in them, and they continue to work and operate, and we've actually go back and refill them year over year. So as we've talked about, it is very resistant to degradation in that regards.
All right. So let's see here. Do we have a coastal engineer on staff? Bishop Water does not, but like I said, we tap into the resources from TenCate. As you can see from the presentation, we have over 50 years of experience, designing and installing these types of systems. So, we certainly can bring to the table whatever experience and staff are necessary to manage a project, or partner with, various consulting engineers. We don't have to do all these jobs ourselves. We're very willing to partner with other firms as well. So, but for Bishop on staff, no, we do not. Take a question.
We do have a civil environmental engineer on staff, but we certainly, as Mark said, we tend to partner with the engineering consultant world, and in that regards from a permitting and application basis, and certainly the regulators like to see a demarcation of work, but we're willing to work with all of our partners to achieve the best project for our clients.
Okay, question that came through email from Richard. So has a concern about vulnerability to puncture due to high angular armor stone, for example. Would they have to be careful about how angular the cover material is? In the case when they want to use blast rock, for example, to cover the Geotube. I guess I would say, Richard, there are other reinforcements we could use. There's other geotextiles from TenCate that can be used to cover the Geotubes. So rather than just putting the stone directly on top of the tube itself, there's ways to to mitigate any damage. But in general, I'd say that shouldn't be a concern. If there was blast rock being used, there are ways to further reinforce the Geotubes. Anything you wanted to add there, Kevin?
No, I think that's great. No, I think that's, yeah.
Okay. And let's see, one more question. What was the water depth when you said Geotubes were deployed offshore in Mexico? That specific application, I'm not as familiar with, but it can vary. I think when you could see the geotube wasn't too far below the surface, but I can look up that information for you. I can dig a little deeper into the case study and certainly get back to you on that. Sorry for not having that info available. Question just came in about repair. If they're vandalized, is there a repair system? And the answer is yes. So the geotube units are able to be repaired in the field should they be punctured. Material can be resewn, and any material lost can be replaced, filled back in. So if there's a prospect of damage, we would recommend, probably one of the Tri-Composite materials be used, which, as we showed, has significant resistance to puncture, and additional protection measures could be used. So if it was a high risk application, for example. All right. And I think that's most of them. I don't see anything else through email. There's some people asking and just asking for follow-up information that we can send out. So we will definitely make note of that. Bob will get you the information you requested on sand-filled mattresses. And I think that's all for questions. Hopefully I didn't miss any. I don't see anything else coming.
I think you got them all.
Okay. Sounds great.
Cheers.
Okay. Yeah, well, really appreciate everybody's time. Thanks again for joining us today. We'll follow up, as we mentioned, with an email and a link to the webinar recording, so a copy, as well as copy of the slides, so and some additional material about the short Geotube shoreline systems. If there are any questions that continue to come through, feel free to send them by email at mark@bishopwater.ca that you see on the screen there, Mark with a C at bishopwater.ca. If you'd like to contact us directly to discuss the shoreline project, just refer to the contact information you see here. So, or you can visit our website at bishopwater.ca. We have a site, some information specifically about shoreline protection posted there. So thanks again, everyone, and stay safe.
Thank you. Really appreciate it. Thanks very much for your time.